You know very well, computer science is very important branch in science, and it is very much useful in every field, in every corner. It may be sports or politics, business, hospital, even in agriculture, so and so forth. In computer science, cloud computing is a very important branch. Uh, Cloud computing, in this subject, you have to get a lot of informations by our today's guest and also my friend and a proud student of the Viveka institution, old student of Viveka institution, Mr. Madhura Upadhya. Presently, he is working as the director of well-known software company at Bangalore, Oracle India. I told already the computer science is very important branch nowadays. Cloud
This
computing.
call is now being recorded.
Cloud computing is a very important branch in computer science. The word cloud computing, it was first coined in the year 1996. And cloud computing means it is the delivery of computer services through internet, such as databases, data storage, servers, networking, softwares, etc. That is why it is most important, useful program. Don't miss it. And once you join the program, at any cost, don't skip the program. If we are having any doubts regarding this, you should discuss with our guest in the later part of this session. I had told already, Mr. Madhura Upadhya, he was the student of this institution, and he had completed his studies 5 years, 3 years high school and 2 years PUC about 30 years ago. And he had completed engineering in computer science in MIT Manipal. Since then, he joined the different software companies, especially very important Oracle India. Since mostly 10 years, he is working in the same company and occupied highest place in this company, working as a director of Oracle India at Bangalore. And so intelligent and very good orator also, and having so a lot of informations in this field, not only in software, even in other field also. He can talk so in any field authentically, Mr. Madhura Upadhya. And one thing, he was a student of this institution, having a close relation with this institution and showing the gratitude, donating the amount, especially to our Annapurna program, midday meal program, frequently in every year. Regarding this, I thank Madhura Upadhya, and on behalf of management and staff, I welcome Madhura Upadhya to this program, and he is utilizing, so he is spending this so one and a half hour with us. For that also, I thank Madhura Upadhya. So directly we shall enter to the main part of this program. Over to Madhura Upadhya. Thank you.
Thank you, sir. Are you guys able to hear me?
Yes, sir.
Okay, good. So let me do your screen. Hope it is 3. Let's see. Can you see my screen?
Yes, sir.
You're able to? Share, okay. Okay. Thank you very much for the opportunity given. Let's see whether I be able to fulfill what you guys are talking, the the expectation, what you have. So let me see. Oh, somehow my screen doesn't allow. Let me see. Somehow my screen is not visible. Let me see what happens. Okay. Anyone has any idea how to share the screen by any chance? Yeah. Are you, can you see my screen or not? Which cloud computing one or which screen you are seeing? Only face, right? Yeah. Yeah. It is not coming up my screen. It is not allowing me to share. Okay. Let me see. 1 second. I think I can. Um, I think yes. Can you see now? My screen, hopefully you are presenting. Okay, visible. Okay, good.
Everything is visible.
Yeah, okay. Sorry, it took some time. So, thank you very much for having me here. Sorry for this delay. Let's get started. So everyone is very eager to hear from me what is cloud computing, um, why it is required, so on and so forth. So the thought process in today's session is mainly give the gist of what is cloud all about, specifically what we are talking about in today's session is going to be mostly the basics of cloud computing. When you need to know more about it, you can reach out to me. I will definitely help you guys to get into the field of cloud computing. So the agenda for today is that we will talk about the definition of cloud itself. Then we will talk about the types of cloud, why cloud is required. Then we will talk about SaaS as a specific property which I want to talk about, meaning what is software as a service. Then, if you want to get into the cloud side of the story, what is required from each one of you, meaning what is the capabilities required or what is the expectation in the industry about the cloud computing. So that is where we are going to talk about today. So okay. So let's first find out what is the definition, right? There need to be a industry standard, we call it, of definitions, right? So National Institute of Standards and Technology, which is the US based firm, which it provides the definition for cloud computing. So in its definition, it talks about cloud computing is a model for enabling ubiquitous meaning it is in all forms, convenient on-demand network access to shared pool of configurable computing resources. When we talk about computing resources, it talks about network, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So each of the cloud model is composed of 5 essential characteristics. 3 service models, and 4 deployment models. So what it says is that it is a form of computing wherein which you will get the resources on network, and it will have certain capabilities which need to be demonstrated. So let's look at all these characteristics first, right? Speaking of cloud, what are the cloud computing characteristics? So there are cloud computing is an IT infrastructure. In general, share the below traits. First one, you should have access to any resources remotely. That means that the resource might be sitting in, say, data center in US, but in from India, you should be able to access it. In general, it is through the public carrier. Public carrier means it is the ISPs, internet service providers, right? Or any service provider. It might be Reliance Jio, it might be BSNL, whatever the case it is. So the first capability of cloud is it should be able to provide you the services on the public carrier. Second characteristic is it need to be scalable. Scalable, there is a other definition, the other word used in the cloud computing world is it need to be elastic. That means that as the demand grows, it need to enhance. As the demand comes down, it need to shrink on demand. It might be the infrastructure, it might be a platform, or it might be an application, whatever the case it is. So it need to exhibit the scalability aspect of computing. Third aspect is pay as you go. That means that it need to provide a capability wherein which as and when you use the system, you will be paying for that. So different companies use different methodologies. There might be a case wherein which, okay, you will be paying for the whole year, then you might get discount. Or you may be paying only on a monthly basis or on pay-per-use. Every characteristics of these kind of payment need to be available in cloud computing. That is the other characteristics. Fourth characteristic is it need to have a quick provisioning, meaning I will order today. It should not so happen that you will get the infrastructure say after 30 days. No, it need to have a quick provisioning capability. If you ask for a certain capability or computing, it should be available say in next 1 hour, next 20 minutes, or next say 3 hours. That is the fourth characteristics. The fifth characteristic is it need to have self-service capability. That means that you should not be calling someone to ask, saying that, okay, can you give me a server today? No, it need to provide you the capability to go into a website most of the time or an application wherein which you will select what kind of server you need, what kind of storage you need, and it should automatically get you that particular computing power. That is the fifth character. So the cloud computing, any provider or any cloud need to exhibit these 5 characteristics. Let's see the service model now. So it talked about 5 characteristics. It talked about the service model. So there are 2 important terminology you should know. One is virtualization. Virtualization means decoupling of service from hardware and layers of service from each other. So that is the characteristics you need to have. That is one of the important terminology. The second terminology is as a service. Okay, you will see that IaaS, that is infrastructure as a service, platform as a service, software as a service. So these 3 service model need to be there in any cloud computing when we talk about. Recent additions over the last probably 3 or 4 years, there are a few additional as a service capabilities have been demonstrated as well as provided to users. That is function as a service and data as a service. In these two cases, we will talk more and more when we get into this particular piece. Then it talks about 4 types of deployment models every cloud need to have. First one is a private cloud. So what is the definition for private cloud? So the private cloud is maintained by the IT department or a vendor. Meaning, if I am a company XYZ, I will have my own IT department with say 10 engineers, a manager, a director, whoever it is. We will be maintaining that particular infrastructure. It might be our own data center, or you can lease some of the data centers. And it is exclusive for your own organization. It will not be used by anyone else. So that is the first deployment model we talk about, that is private cloud. It is within the organization. Second one is public cloud. In the public cloud, it is purchased from a provider on demand, meaning there are so many providers. It might be Oracle, it might be Google, it might be Amazon, it might be Microsoft Azure or Alibaba Cloud, so on and so forth. There are so many providers available. So public cloud will be purchased from a provider. Second characteristic, you are one of the many clients. It is not necessarily only for one particular organization or one particular individual. There might be hundreds of customers required or available on that particular platform. So you are one of the customers for the company. It is a shared responsibility, meaning infrastructure might be managed by the provider, but the responsibility of security lies with the individuals. So if I buy a service from, say, Google Cloud, I need to make sure that the security of my users, the access, everything is my responsibility. So it becomes a shared responsibility for everyone who is using the public cloud infrastructure. Next one is hybrid cloud. So in the hybrid cloud, you will be having multiple providers. And second part is mostly combined with private and public cloud. So you will have, say, one private cloud vendor, say Oracle or Google. Then you will buy one more vendor, say Microsoft Azure. Now you want to combine these two. Then it becomes a hybrid cloud. So when a private and public clouds are combined, you will call it as hybrid cloud, or two cloud providers providing the resources for a particular organization, and it is having an integration and connectivity between two cloud or the private and public cloud, then it will be called as hybrid cloud. The fourth one, which is not necessarily commonly used, that is known as community cloud. In the community cloud, the definition came in because of it is going to be used by a specific community of consumers from organizations that have shared concerns, meaning highly secured cloud requirements from, say, multiple defense organization in a country. Then it can be considered as a community cloud. So it can have multiple providers, and it will be owned by the community. So these are all the 4 deployment models. So if you refer back to my first slide, it talks about 5 characteristics, 3 service models, and 4 deployment models. That's what it is. The characteristics of remote connectivity, the characteristic of the elasticity, scalability, self-service, and instant provisioning. Those are the 5 characteristics. 4 deployment models: private cloud, public cloud, hybrid cloud, and community cloud, plus 3 service model in general, that is infrastructure as a service, platform as a service, and software as a service. Now let's go into why cloud, right? Because now you have seen that okay, it need to be consumed over the carrier. You need to have an internet connection. Then what is the requirement for cloud? In cloud, you are paying for results or service. So you are paying only for that particular piece. You are not paying for, okay, hardware, I need to pay this much. For software, I need to pay this much. For platform, I need to pay this much, right? So you are paying for the end result. End result is I am having an access to an application. That's it, right? Or a service infrastructure as a service. I will say that I need a server with 100 GB memory plus you will be having say 10 CPU core, right? So in those cases, how you will get that, right? So you will be paying for the result, not for the not for individual component. You are not paying for hardware, okay? You are paying for what you are getting. That's it. That is where it ends. It is like taking a taxi or buy a car, right? For example, you are using, for example, coming to office and going back, or I don't want to own a car because I need to pay insurance on every year. I need to go for servicing. I need to take care of its tires, so on and so forth, right? Each of them are an individual component. If you have capability, absolutely yes, you can go and buy it. But I have a limited amount of resources. Now I want to, instead of buying the car, what I can do is I can just go and get the resources, meaning hire a taxi, right? Once you get the taxi, your job is just to make sure that you are going in the taxi, call them, get your uh, from point A to point B, you can go and you can done, right? So you are paying only for that particular piece. You are not paying like 8 lakh rupees in the beginning of the period where you buy the car and you use it only for 10 days in a year, right? Instead of that, I can pay 8,000 rupees per day, take car for 10 days, right? So that is the difference. Now let's look at one more aspect. Often we call this as moving from capital expenditure, wherein which you are spending a lot of money in the beginning itself, into operational expenses. That means that every year you are paying one at a time. So that is what is called as a capex versus opex. Okay, so that is the difference between how you will use car as an analogy, and moving, instead of buying a car, you are paying for as soon as you are using the car, you are paying for that particular number of kilometers. The hardware and the equipment's provision to provide you your service can grow as your service grows. For example, you start with a small company saying that, okay, you have only 10 users. Tomorrow, you will be having 100 users, or you might become 1,000 users. So the provider will make sure that as you grow in your company with the with the number of users or requirement, the CPUs, the memory, or the network, everything the provider will take care as you grow in the organization. So that is the other aspect of it. So now let's take one particular aspect of it and talk about the software as a service. So let's look at the characteristics of that. SaaS means software as a service. It is a cloud-based application, and 99.9% of the time it will be web-based. There are applications which can be run in your desktop, but it connects to backend in the cloud and run on the servers located in the cloud. The servers which we talked about will be owned and managed by someone else, that is the cloud provider or a central IT group. They will manage those hardware and the services. Servers can be of any other AAS, that is, for example, you can build your software as a service application on top of infrastructure as a service, or you can have a platform as a service, and on top of that, you can write your own application and you can provide it to different people. And it will include the network infrastructure, the DNS, routers, virtual private networks, virtual LANs, storage, operating systems, so on and so forth. But none of that is visible to you as a consumer of an application. For example, take example of this Meet, where we are. It is from Google. Google Meet is an application which runs on the web. You don't know how much, what server they are using. You don't know it. What kind of application they are using, you may not be knowing. You are just a consumer of Meet as an application, right? Or say, other example is like Gmail or Facebook or LinkedIn or your YouTube, right? You are using just an application. In the back end, where it connects, what kind of servers they have, what kind of storage they have, what kind of bandwidth it is using, we are not bothered about it, right? We are just a consumer of the application. So that is what SaaS is all about. And there will be a service level agreement if you are using the enterprise level application. Most of the cloud providers will provide the service level agreements in terms of nines, meaning 5 nines, 4 nines, so on and so forth. It is like 99%, 99.99% of the time, your application will be up and running. That is the service level agreement which will be there on the paper. If any organization not able to meet that particular uh, contractual obligation, then what happens is that they need to pay back. So we need to define contractually what standards will be met by the provider and what rebate compensation is available and should they fail to meet. So that is what I talked about. If a specific contractual obligation is not met, then what happens is you will be paid back or you will be offered some other services free of cost. One other aspect which I wanted to touch upon in this particular session is security on cloud. Because every application currently, because of the pandemic, we are in a situation where in which everyone is using more and more of components which is available in the cloud, right? So security on the cloud, every one of you need to know that it's a shared responsibility. So if you see the topmost portion, right, the data governance, the client endpoints, and the account and access management, it is always retained by the customers. So, for example, if you are using a Meet or Gmail, right, your password or access mechanism is your responsibility. The provider, Gmail, will not help you in that, right? For example, they might help you to retrieve your old password or help you to reset the password. That's it. They will not be knowing what password you are using to access it, right? So it is a shared responsibility. So if you see the vertical SaaS, PaaS, IaaS, and on-prem, if it is blue, that means that the customer is responsible for it. If it is gray, that means that it is the responsibility of the cloud provider. For example, let's take an example. In the SaaS world, right, the software as a service, the physical host, the network, the data center, and operating system, network control, application itself, till that moment, it is the responsibility of the cloud provider. But when it comes to the identity and account management and access management, the responsibility lies with the individuals or customers. But when you go to the rightmost side of on-premise or a private cloud, all these responsibility lies with the customer because he has full access to the infrastructure which has been provided by the service provider. Let's park this cloud discussion at this moment and go to one piece of advice for everyone who are in the call. It is not possible to write completely bug-free software. Okay, this you need to keep it in mind. At any point of time, there will be issue, there will be bug with the software. Even a simple piece of software are not fully testable. Okay, that means that any software which you are using on the system will have bugs. Because when you grow as a engineer and you become a software engineer or cloud engineer or whatever, you will write the code, but every scenario cannot be tested. So that is why bugs will be there. Even if you are able to possibly write error-free software, given the number of software being used by different people, there will be bug, undiscovered bug, which will be there, like security bugs, right? It becomes a security bugs over the period of time. So the best that can be done is to leverage the best practice methods, tools that have been developed by security community to make sure that from the inception of your software till you deploy it, it follows the secure method so that you can reduce the risk in developing software and providing that software on the cloud. So let me take you guys to the career in cloud, right? I would like you to say one thing. It's an open ground for all streams of engineering or science, or it might be commerce as well. I'm not debating on that particular aspect. It is a interest in knowledge in the operating system, network, storage, server, which is essential for career to be built in cloud. The programming knowledge is essential. I would tell all the people who ever come to me for advice, I tell them, you need to be strong in your logical aptitude, plus how you can break down the bigger problem into a smaller one. Okay, that is exactly is required. And programming knowledge, whether it is Python or Java or C or whatever the case it is, you need to have a solid knowledge. Don't worry which programming language it is, because different programming languages will have syntax difference or the way in which it gets executed. That's it. So the logic flows 90% of the time it is same. One other thing, cloud always runs, right? Cloud will not be shut down in the evening and morning I will come and start it up. So you should be ready to work 24/7, meaning your cloud, you are working as a cloud engineer. It need to be up and running always. And if it happens that, okay, in the night, you will be called to fix a bug, then you should be ready. So that is what it is. So you should be ready to work these kind of environments. Not necessarily always, but in the new site reliability engineering way of working, any issue which happens over the period of time, then you will be coming and you will be providing that solution. Development methodologies you should be knowing, whether it is a waterfall method or the latest ones are mostly the agile framework which has been used. I will briefly touch upon that particular aspect in the later stage of this particular session, just to give a gist of, okay, what are those. There are things called design patterns. You should be knowing cloud design patterns. That will be helpful over the period of time, not necessarily in your 12th standard or 11th standard, but once you cross engineering, when you are doing the engineering, it is better to know the design patterns, both from the software development perspective as well as from the cloud design perspective. The new role which is defined by Google probably for like 7 to 8 years now is site reliability engineers. That should be your target, wherein which you are a developer, you are operating the that particular system also, and you should be able to fix that issue as well. So that is known as site reliability engineering. Let me give one piece of advice. You can, because there are so many providers in cloud. Different people use different terminologies when we talk about cloud. So I would provide you guys with this particular website, comparecloud.in, a pretty good website, which gives the category of what we are talking about, compute, what service they offer, and different providers, what they call it. For example, in the compute side, if you see compute, virtual server, in Amazon, it is known as EC2. In Azure, it is known as virtual machine. If you see Google Cloud, it is known as GCP or compute engine. If you see IBM Cloud, it is known as different names. There are 5 or 6 names. In Oracle, we call it as compute. In Alibaba, it is called as ECS. So each provider have different names. So don't get bogged down by that. Just go in this site and look at what is best for you. Okay. So have a look at this. With that, I think I will stop at this particular stage and take question. After that, probably another 5-10 minutes, then we will talk about briefly about the development methodologies. Will that work for all of you guys? I think Anagha?
Thank you, sir, for such an informative session. So, with your kind permission, we are starting Q&A session so that all the students can clear their doubts. I request all the students to post their questions in the chat section so that selected questions can be answered.
I saw somebody has asked for a question.
Rajan, you can ask the question now.
Yeah.
What is the difference between cloud computing and mobile computing?
Okay, so I will give a generic answer. That means that in the mobile computing, you are using a computing resource as your mobile, right? So you might be using a lot of application from your mobile and use those application to access certain resources in the cloud. So it both might be related as well. So it is a related terminology, not necessarily a differential terminology as such.
Ranjitha.
Okay, I think I saw that message. How can we secure? How can we secure the data for transport in the cloud? So there are different ways in which the data has been data transport will be secured. One is using SSL, secured socket layer, in which the data between the two endpoints, we call it, from say for you from your laptop to the cloud provider, for example, you can encrypt those using SSL. So there is something called SSL certificates, which is used. In most of the cases, you need to have that, either virtual private network or SSL kind of technology you need to use to secure your data. But from the cloud provider perspective, we call it as data at rest. That means that once the data is stored, that is 100% secured. But the transport layer, it is the capability which need to be used between your device, how you are using from the customer perspective, till the endpoint of cloud. That's how it works. So in general, we use the SSL. Which are the
ask the question?
Yeah, I saw that question. Which are the APIs used in cloud computing? This might be like thousands of pages. Okay, each provider has a documentation on what are all the APIs they expose to the endpoints. Meaning, from your server. Let me throw up some specific terminologies. There is a capability using Terraform. Okay, Terraform works on any of the server or laptop. You can write your own queries and you can run those. What happens is it uses the API to access the cloud provider, and end-to-end automation can be done. For example, you want to spin up say 10 servers. Okay, that can be written in your API itself, and using Terraform you give the end state what you want to see. It can go back to the APIs and get executed on the cloud. So every cloud provider provides the APIs for different capabilities in their uh, in their cloud. So it is going to be like thousands of pages. You need to go to their documentation and read it. Next question from India, which says that which are the different layers which define cloud architecture? Okay, from the it has different meanings in cloud. One is we call it as physical architecture, where in which you will have say data center, servers, power, network. Then after that there are access switches. Then there is a top of the rack switches. Then you have the gateways. Then you have firewall. Then load balancer, so on and so forth. So I can provide those kind of details when you need it, but it is a very, very complex design.
Next question is from Akash.
Akash. Okay, what is the advantage of cloud computing? I briefly touched upon in why cloud computing. It is because there is no need to pay in the beginning itself for the whole hardware, software, whatever it is. As soon as you read those things, then as and when you use the resources, then you will be using it. So it is like I talked about. Buying a car versus renting a car. Okay.
Another question from
Let me just check. Is there a demand for cloud developer in the market? Absolutely, yes. Every day and day out, if you go and see, there will be 10,000, 20,000 jobs which are required for cloud developer. As I said, I think I put together certain requirements for people who want to become the cloud developer. Definitely, yes, that is the way forward. It may become like $1 trillion business in short term. Next question is what is Eucalyptus in cloud computing? Why it is used, sir? So Eucalyptus is if I remember correctly, it is a open source software used for creating the hybrid or private cloud on specific to AWS, if I remember correctly. That is what it is. What are the demerits of cloud computing? Very good question. As I said, security is the shared responsibility in cloud. So if you breach that security, there is a possibility that every data can be exposed. There were cases in the beginning of this one, it happened. That is why it's a shared responsibility. Data, no need to worry about it. It is taken care by the provider, but your users and other things, individuals need to be very, very careful. That is the only one thing which I can think of. Second one, usually we will be having multiple cloud network providers. But for example, if say earthquake happens, all the network connectivity from US to India gets broken. That means that you cannot use your computers, right? So those kind of demerits will be there in the cloud or anything you are using it in the internet. Whatever you see as a issue in internet, same thing will be there in the cloud as well, cloud computing as well. Why IaaS, PaaS, and SaaS is made? What are the application of these? Okay, infrastructure as a service. For example, you want to build your own application. Okay, I don't want the existing application to be used, then you can buy infrastructure as a service. Then you have server available to you. You deploy whatever the application you want to deploy. Nobody is going to question you. So that is the simplest use of IaaS. In the past, it is the platform as a service, meaning up to, say, a database or the middle tier services like Apache or WebLogic or um, any other IaaS kind of services will be available. You just need to deploy your application. SaaS is pure end-to-end software which is available. You can just use the application. No need to worry about what database is there, what network is there, so on and so forth. That is why SaaS comes into play. That is why it is. Sir, why cloud design pattern is important? Mainly design patterns is like how you need to write your application or how you need to divide your application. For example, there is a design pattern called N+1. That means that instead of having only one middle tier or one database tier, you need to have N or N+1. Meaning, if one server goes down, you can have the second server up and running. So instead of like I remember your probability theory, right? If you have a coin, what is the probability of getting head? If you have one coin, if you have two coins and you spin up, the probability increases by 2, right? You will have a better chance. It keeps coming down. So that is why design patterns are very, very important. It gives a way in which you can think how software need to be developed, how it need to be deployed on the cloud. So from that aspect, the design pattern is very, very important. I would suggest you guys just go to Google or in YouTube, just search for cloud design pattern and you will get it. Okay, with that.
Any more questions?
Any more questions? Or,
sir, I had a question, sir.
Yeah, go ahead, Anagha.
Sir, how can cloud computing help in space exploration, sir?
Okay, so space exploration requires a lot of computing power to. Okay, let's take a step back. In space exploration, what happens? You will be having a lot of the telescopes, right, which keep monitoring the overall universe, right?
Yes, sir.
What happens is every minute or every second, it takes say 25 to 30 pictures, frames per second, right? That is what is called as. To do the analysis of that, you need computing power, right? If new things has been found, they need to keep monitoring the pictures. Every picture need to be looked at to see whether there is any change or any new object has been found, right? I am giving a simplest example. When you are having telescopes worldwide, right? When you combine all these things, what happens is every second there might be billion, say, pictures which is coming in, right? If you put your own hardware, you need to keep building. As and when you are having more pictures coming in, you need to add new servers, right? It takes time. Instead of that, if you are using the cloud provider, what happens is they will provide you this computing power. As and when, say, next 2 months, I will be using all the telescopes, but after that, I will give break for, say, 50% of the telescopes. I will not be looking at those. What happens is this, the elasticity of cloud computing comes into play here. So when you need more computing power, you will get it. There are cloud providers who we provide the GPUs, the graphical power as well, so that you can write your own algorithm to monitor all these space explored, say, pictures, so that you can identify using artificial intelligence or machine learning to get to the exploration part of it. So instead of worrying about like whether my IT computing power is sufficient, here what happens is I'm more worried about, okay, how I will write new algorithm which can go and find out whether there is a new object in the universe.
Okay, sir. Sir, I have heard that autonomous cars are cloud robots, a type of cloud robots. What measures can be taken when cloud fails in such times?
Okay, so there are two concepts in the autonomous cars. One is connected cars, and other one is the cloud. What happens is every car generates lot of signals on a daily basis, on every second. Okay, for example, it will have sensor for temperature, it will have sensor for AC, it will have battery, it will have whether the motor is running properly or not, so and so forth. All this data in the normal car, what happens is it is stored in ECU, okay, within the car. When you take the car to the service station, they will connect your car to the computer to identify is there any problem. In the cloud-based autonomous cars, what happens is the data will be continuously sent to the cloud provider, the car provider like Tesla or whoever, right? They will be keep monitoring it to see is there any pattern or is there any failure which is coming in your car, so that they can make sure that before you know what uh, before you even know that your car is going to break down, they will be knowing and they can arrange for car parts, so and so forth. So that is the advantage of using cloud computing power with autonomous cars.
Okay, sir. There are many more questions in the chat.
Yeah, a few
sir.
more questions I have seen. Is there any validity for SSL certificate in any software? I'm not getting that particular question. I would suggest you guys to send that question to me. I will answer that, what exactly it meant. Because SSL certificate sits in the load balancer or not in the firewall. I think it is in the load balancer. So uh, the connection between the load balancer to the your server is always encrypted. So that's how it works. What are the job opportunities and facilities for a cloud developer? Job opportunities are immense. You need to just focus on your studies and get good score. And I would say that not necessarily score. You need to broaden your knowledge about different technologies which is being used, which I talked about earlier. Which platforms are used for large-scale cloud computing? I'm not able to make out whether it is specific to infrastructure or from other aspect, because currently there are servers which comes with say like 300 to 500 CPUs. Okay, so those kind of hardwares are used in most of the cases. So large scale computing, when it comes to play, it is not that you will be abstracted from how this load has been distributed. For example, when you are connecting for the first time, you might be connecting to server A, but when in the next time when you try to connect, it might go and connect you to server B. So that is the advantage or beauty of cloud computing. It abstracts where you are connecting to. Okay, so that is what happens large scale computing. Any disadvantage like hacking? Absolutely yes. I talked about it. In the security is paramount in the large scale cloud deployment, as well as any cloud computing for that matter. It's a shared responsibility between the cloud providers and the consumers, including when we use say YouTube or Facebook or Gmail or whatever the case it is. Make sure that your software is your password is safe, and always try to have two-factor authentication, meaning not only your password, it will send one more 6-digit kind of code to your mobile. Only those two matches, then only it will allow you to logging in. Yes, hacking do happen, meaning they try many times to access any cloud provider. We have a lot of security softwares in front of our cloud endpoints, which can identify these kind of hacking attempts. Okay, with that, I think I'm good. If you guys want to have a quick 5-minute session on database, like the design principle, or like Facebook also has password, but it is hacked. Yeah, absolutely. Facebook can be hacked because there are set of always known passwords. Okay, I'll give an example. Many of you might be having a passwords, which is your date of birth, okay, or your school name, or your second name, or how you are pronounced in your home, right? If anyone knows those kind of things, they will try to keep using those patterns of your passwords. There are known patterns in the password, like admin12, welcome1, right? School1. So those kind of passwords are known. So the hackers, what they do is they use these kind of patterns and they try to access to your accounts. That's how it works. What about VIP's accounts? Anything can be hacked. Okay, keep this in mind. Any account can be hacked. Okay, only it is time required for hacking. Okay, so what happens is, for example, you are having, say, 4-digit password, for example, right? So how many attempts it requires, right? It is 9999, right? He will start with 0000 and goes up to 999. So one of that number might be your number, okay? That is, for earlier ATM pin used to have only 4 digits. So that is how it used to be done. Then they changed it to 8 digits. Then they changed it to, say, 32 digits, so on and so forth. Now what is happening is we get to use different technologies altogether. We call it as FIPS and YubiKeys and other things. There are hardware with software, which is available, which combines the like up to 256 characters. So it can be hacked, but it takes like years together to identify that particular pattern. So they will not be having that much time. So hackers trying to get money as early as possible. So they will not be having time to do this.
Any more questions?
Okay.
So one last question
Yep.
from my side, sir.
Yes.
Sorry for the trouble.
Go ahead.
If suppose an astronaut needs access to some data from the cloud, sir, will it be able from till the faraway distances?
Yes, absolutely.
Available, sir?
Yeah, only thing required is that he need to have access to internet.
Yes, sir.
Right?
Is it possible?
It is possible
Faraway
because
places?
you must have seen like if you go and see um, SpaceX launches, right? There is a lot of data which has been sent from SpaceX satellites or their rockets to the ground. There will be a bit delay, but yes, absolutely, it can be accessed.
Okay. Thank you, sir.
Okay. Any more questions?
Okay. Thank you so much, sir, for us answering all of our questions. We are ending the Q&A session, sir.
Okay. Thank you very much. Do you guys have another 5 minutes? I will quickly probably go through the development methodology slide.
Yes, sir.
Couple of slides, okay?
Okay,
Okay,
sir.
so let's move ahead. So let's talk about how software is being developed. You guys able to see my screen?
Yes, sir. We can, sir.
Okay. So any software development is any software being developed. It follows certain methodologies. Okay, it is known as development methodologies. So let's in the beginning of like probably from last 40 years back or whatever, we used to call it as waterfall method. Now there is a new method of developing the software called agile. Okay, so we will talk about that. So I think you must be knowing this particular piece called SDLC, right? Software Development Lifecycle. So it starts with communication. That means that where there is a software product which is required, which is desired. So that comes as a communication, right? Then what happens is second part is known as requirement gathering, where in which you will gather the requirement. What application I am going to build, study the existing or obsolete system and software, conduct the interviews with the users and developers to identify what is required, look at different questions what is customer looking at as for developing a software, right? That comes in the requirement gathering phase. Then look at the feasibility of developing that particular software, which is known as feasibility study. Okay. Once you've done requirement gathering, you come up with a team which can build the software for you, right? So they will look at, okay, which software, whether this software can be built on the time, whether there are algorithm available, whether it can be done in the day, time, whatever the money you have. The next phase, we call it as system analysis. In this, we will create the roadmap for the plan. What is the best software model suitable for this project? What are the limitations? What is the learning system related problems? With the existing system, how it need to be modified, so on and so forth. So that is called as system analysis phase. Then it goes into requirement and analysis has been done. Now you start designing the product. Designing doesn't mean that you start coding immediately. No, it need to have, okay, what kind of screens are required, how the communication between different modules happens, so on and so forth. So then what kind of tables are required to store the data, logical diagram, how the data flows, then create some pseudocodes, right? Mainly pseudocodes will be written saying that, okay, if this happens, this is what need to be executed. Then the actual programming phase comes in, right? That is where we call it as coding. You start coding your software, then it will go into a testing phase. Estimate says that 50% of the whole software development process should be tested, meaning any code, it need to be tested, right? From the capability perspective, from the usability perspective, security perspective, data perspective, every bits and pieces of testing need to be done. UX, we call it, user experience. That is one of the important aspect of how software need to be built. Then if there are multiple software systems available, how integration happens between different pieces. If, for example, there is a middle tier services, then there is a database service, how the integration need to happen, is there any connection pooling required, what kind of deadlock detection need to happen, so on and so forth. Then once this code is ready, then it need to go into the systems, right? Software is built on your laptop, probably, then it need to go into a server. So that is what is the implementation phase. Then the next phase is operation and maintenance, meaning the every application usually will have like 5 to 8 year kind of time frame, meaning it takes that much time. So you need to maintain that. If you identify a bug during that time, it need to be fixed, or if something breaks, then you need to fix that. One other piece which generally people don't talk about is disposition. That means that after the life cycle of particular software is come to an end, how you will dispose that particular application, right? Because there is a data already existing, you need to make sure that it goes into archival, so that if it after 18 years, say IT department asks for certain data, you should be able to provide that. So archiving and disposition of software also is very, very important from the software development lifecycle perspective. Then we will look at paradigms, right? In the waterfall method, because from the requirement gathering till the operation, it is like a waterfall. The water coming from the top, used by the second level, and going to the third level, so on and so forth. So it is in a step, right? One after another. In the recent past, from say 5 to 8 years, there are paradigm shift happened, which talks about iterative model, okay, wherein which you take a small, the model leads to development process in iteration. It is not that till all features as completed, you will not deploy the code. It is not like that. You start with the basic features, deploy it, people start using it, then create the next set of new features, add it. Okay, it goes into the iterative model, but in each of the phases, it follows the SLDC process. So the software first developed on very small scale, all the steps are followed. Then in the next iteration, more features are added. So like that, it will continue. So it keeps continuing. That is known as iterative model. Agile is one of the framework which is used by many people. Next one thing, I think somebody asked about the architecture. So earlier we used to have something called monolithic architecture, wherein which say the top UI means a user interface. Okay, so like your web page or whatever. Then the whole business logic is written in one single piece, and you have a database. So it is one-to-one piece. This is known as monolithic architecture. Most of the application till say 2 years back, 2 or 3 years back, used to be the monolithic architecture. Now a new word has come in that is known as microservice architecture. What happens is this business logic is divided into pieces and is goes into different architecture altogether. So it might be having multiple databases as well. The best example is if you go to say Amazon.in, when you go in, it has different microservices in the backend, which you will not be even knowing. One is say searching. Search of product might be a one single application. The cart might be a different application. The payment service might be a different architecture. But as and when you divide your single application into microservice architecture, what happens is the complexity of data flow also increases. So you need to be very careful when you are building your microservice architecture because the complexity of your application development also increases. Okay, so that is where I end my session today.
Thank you so much, sir, for such an informative session. Now we are ending the webinar. I request Ranjitha to give vote of thanks.
Good evening, everyone. Myself Ranjitha, and I'm here to present vote of thanks for today's webinar on behalf of our institution. I'd like to thank our webinar speaker, Mr. Madhura Upadhya, for their presence and enlightening us with their knowledge. Today's webinar was informative and interesting. It gave us deep insights into the topic and also revealed some fascinating facts which we didn't know about. I'm pretty sure that the knowledge shared by Mr. Madhura Upadhya will definitely help us in higher studies and future. Once again, I'd like to thank Madhura Upadhya for taking out time from their busy schedule and share their knowledge with us. Thank you so much, sir.
Thank you very much, everyone. It is a The questions are very good. I would say all the best to all of you, and thank you for having me. Thank you.
Thank you, sir. And also, I'd like to thank our principal, Mr. Jagadish Navada, for organizing this webinar. Thank you, sir. I'd like to thank ex-students of Viveka College, Sanat Kumar Udupa, of Brickworks India Limited, Shilpa Oracle Cloud Services, and Aditya Shanai. Thank you for the management and members of Kota Vidya Sangha and also lecturers of Viveka PU College, Kota. At last, I'd like to thank all the students for attending this webinar. Thank you, one and all.
May the coming year bring all the happiness and success to everyone. Thank you, one and all.
Sir, can we leave, sir?